Okay, we are live. Let's begin this. Special shout out, Sidney Osoto. Okay, now, here we go. Your calculator. We're going to do a crash course on the calculator. Turn them on. Everybody hit the home button. Top right, hit home. Look where the mouse is. Top right. Listen to what I say. Hit 1, new document. Always, whenever you get a calculator, always start a new document. Do not save any changes. Don't save anything. Start fresh. Add a calculator. So we got page 1 of file 1. Hit home again. You're going to add. This time, go down. Don't ever play around in the scratch pad. Scratch pad is useless. Don't ever use it. Go right here. Come to the blue parabola. Let's add a graph. Hit enter. So you should have 2 pages open. We've got page 2 is a graph. Page 1 is a calculator. Okay, now on page 2, let's do this. If you want to go back and forth, you just hit the yellow button on left or yellow button right. So on your, everybody go to the graph. Hit menu. Menu's in the top right-ish. Hit menu. And let's go to view. Option number 2, click on view. And under the view menu, turn your grid on. Go to 6. And let's do aligned grid. Your graphs are much easier to look at if you're looking at them in aligned grid. Okay, now, here we go. Let's set that aside. I don't think we're going to use it for a little bit. Problem number 1. Okay, 1 and 2. I'm pretty sure these are not going to be on. They're definitely not going to be on your final. I'd be way surprised if they showed up on Sage. I don't think they're going to be there. But, I don't know. Some of these Sage questions, I think they throw you some junior questions. And there's even a couple 9th grade questions. So, number 1. Okay, look, this is function notation. Function F and function G. That's pretty simple. That's just an abbreviation. Maybe F is Freddy's function and G is Gary's function. F and G are just abbreviations. So F says this. It is the same thing as Y. Y equals 3x plus 1. And so let's go look at your calculator. If you hit your, if we go to our calculator, that's in function notation. So F1, we can graph like 10. So everybody type this in. If you hit 3, okay, the X is down here on the bottom row of the alphabet. Let's go 3x plus 1. This is a linear function. It should just be a straight line with a slope of 3. And it goes through the y-axis at 1. So just a typical linear function. Now if we look at, let's look at G. So G, now this is also the same thing. That's the same thing as Y. So we got y equals x squared minus 5. So this was your sophomore math. We introduced degree 2. We introduced quadratics. Quadratics have the shape of a parabola. Linear, the biggest exponent is 1, so degree 1, that's linear, and it looks just like some kind of straight line. So let's type in this quadratic. Let's type in x squared, take away 5. So if you go on your calculator, hit tab. So tab's kind of in the top leftish. Hit tab. And it should bring this up. Should bring up function number 2. So function number 2, let's go x squared. What was it? Minus 5? X squared minus 5. Hit enter. And there's the parabola. So, now, let's look at number 1. Okay, number 1. So this was for you guys just a straight up guess. A, B, C, D. Function f is a linear function. G is quadratic. They want you to evaluate g. Everybody write this down. Let's do g of f of 3. Okay, Tyler, please stop talking. Let's write this down. We're going to change it. They want you to do g of f of x. It's easier to understand the arithmetic before we hop into the algebra. So if they want you to evaluate g of f of 3, here's what they want you to do. They want you to take 3 and plug it in to the function f. So let's do that real quick. Now f says this. F says whatever you plug in, you just times it by 3. So f's rule is this. I'm going to do 3 times whatever I let x be, and then I'm going to plus 1. And what they're telling you to do is let x be 3. So take 3 and substitute it in place of the x. So really the arithmetic is 3 times 3 plus 1. And we get 10. Now, you are going to take that answer. You're going to take 10 and you are going to plug it into g's function. And g says this. G says whatever you plug in place of x, the first thing you do is square it, and then you subtract 5. So I'm going to take 10 and I'm going to substitute it in place of x. So it's going to be 10 squared subtract 5. And 10 squared is 100. And 100 minus 5. So I'm going to end up at 95. If I take 3, get busy, and I plug it into f and I plug it into g, I'm going to end up at 95. We're going to go abstract. So here's what we're going to do. We are going to take x and plug it into f, which is already done. It's already done. So f of x says this. You times 3 by whatever you want to plug in, and I want to plug in x, so I just plug in x, and then I plus 1. Okay, now that is my answer. So I'm going to take this answer, and now I'm going to plug that into what g says to do. And g says to do this. G says whatever you plug in, you have to square it, and then you've got to subtract 5. Now I'm not plugging in a number 10. This time I'm plugging in this algebra. So I'm going to plug that into x. So that is 3x plus 1, and then I square it. Then I take away 5. Now to square this, you just take it and you multiply it by itself. So 3x plus 1 times itself, 3x plus 1, and then I'm going to subtract 5. So I got to do a lot of distributive. So if I do 3x times 3x, that will give me 9x squared, and then I got to do the 3x times the 1, and that's a 3x. And then I do 1 times 3x, and that's another 3x. Then I do 1 times 1, and then I'm all done. I do minus 5. And now combine your like terms. So 9x squared, 3x and 3x, those will simplify to total 6x's, and 1 and a minus 5, that will total to give you a minus 4. And that is your answer. So that matches up with D. So now using this idea and following this, C2 is the exact same thing. So look at 2. 2, they're going to give you a function f, and that's 2 times x plus 3, and a function g, and that's x squared minus 1. So now this time they want you to take x, plug it into f, and then take that answer and plug it into g. So see if you can play around on number 2. See if you can get the right answer. So you're going to take x and you can put it into f. Now f says this. F is 2 times x plus 3. So if I take x and put it in place of x, that doesn't really do anything. It's going to stay 2x plus 3. But now I've got to take that. That's not going to simplify to anything. You're done. You're going to take that though, and you're going to plug that in to G. And G says this. G says whatever you plug in place of x, you square it, and then you minus 1. So I'm going to take this whole thing, the 2x and the 3, and I substitute it in place of x. So it's going to be 2x plus 3, but I got to square it, and then I got to minus 1. So to square it, the only way you can square these two terms is if you do 2x plus 3 times 2x plus 3 minus 1, and then the 2x times 2x, that's going to give you 4x squared. 2x times 3, that's going to give you 6x. 3 times 2x, that's going to give you 6x. 3 times 3 is going to give you 9. Take away 1. It is C. Dang. It's going to end up with C. 4x squared, 6x, 6x, that's going to be 12x's. 9, take away 1, that's going to be 8, which is C. Okay, let's look at number 3. Okay, number 3. Now look, this is a 9th grade question. You guys did this freshman year. Your y-intercepts. If you're looking at a graph, no matter if it's a quadratic, no matter what it is, there are x-intercepts and y-intercepts. This guy right here, and this guy right here, and this guy right here. These are your intercepts. Wherever it crosses, in this case, the y. So the y-intercept. So let's test this out. If I graph this dot, 0, 2, that means I go 0 and up 2, boom. Over 3, 0, dunk, 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 dunk. Left 3, up 4, boom, 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 boom. Right 6, down 2. So it looks like a linear, all these dots look like they're going to fall to a straight line. Now, which of these dots is the y-intercept? And that is the dot that is on the y-axis. So this guy is our answer. And that is A. So this one was pretty easy. You got to remember these. X-intercepts. These right here are your X-intercepts. Wherever they touch the X-axis, those dots are called your X-intercepts. So draw yourself a little picture. Put the dots down. So I don't know. I don't know if this is going to show up. Number 4. This X-intercepts. So do the same thing. Over 1, up 2, that dot's like right there. Over 3, 0, that dot's there. Over 2, up 1, that dot's there. Over 4, down. So it kind of looks linear again. 0, up 3. So boom. Which one of these is the X-intercept? It's that dot right there. And that dot is this dot. Over 3 and 0. So A again. Okay, number 5. What is the X-intercept of this graph? Now check this out. Here's what you know about intercepts. Look at this. Intercepts always have a 0. The X-intercept has a 0 there, and the Y-intercept has a 0 there. If you're going to land on one of these axes, so for me to land on the X-axis, that means my Y is 0. B. Smith. Shout out to B. Smith. Welcome. Let's pause and get B. Smith some homework for today. Look. For me to end on this X-axis, that means X could be anything. X could be 100. But the Y, the up and down, you have to have that as 0. So if I go over 100, I cannot go up or down. As long as your Y is 0, that will guarantee me to land on anywhere on this number line. X could be -5, but Y has to be 0. So I go over here, -5, boom. So that is the X-intercept. Your X-intercept is this. The Y, you cannot go up or down, so the Y must be 0. So you're going to take 0, and you're going to plug it right there in for the Y. So it's going to be 3 times X minus 2 times 0 equals -12. And -2 times 0 is 0, so it's 3x equals -12. Divide by 3, divide by 3. Paching. If I know my y is 0, that's only true when my x is 4. So, B. If I go over 4 and 0, that is a dot that's going to land on the x-axis. If I wanted to know what dot lands on the y-axis, then I'd put 0 on the x and solve for y. So 4 and 5 and 3 are all kind of review freshman stuff. Huh? Oh shoot, might be -4. Okay, listen. Everyone, pause, time out. Vanessa Marquez very wisely pointed out it's A, not B. Because look, this guy right here. A -12 divided by 3 is equal to a -4. So, if you see Vanessa in the hall, buy her a swizzle. She likes tropical, the blue, tropical oasis, the blue one, every day. Okay. Now, don't get lippy, Tyler. Okay, 6. Now, this is it. This is us. This is this year's stuff. Now, check this out. Which graph is represented by the parabola y equals x squared plus 7x plus 11? Everybody do this on your calculator. Okay, if I'm getting too much stuff on this page, everybody at home, let's add a new graph. Just hit enter. Now I got a blank graph. Now look, Hannah, this says F3. This is going to be my third graph because on this page right here, that's my first graph, that's my second graph, so F3 is just my third graph. Type it in. Everybody type this in. You're going to type in x squared plus 7x plus 12. So type in x squared plus 7x plus 12 plus 11, not 12. That right now? X squared plus 7x plus 11. Okay, hit enter. And it's, if you want to turn the grid on, the grid helps. Just go menu. It's under view. And then it's under 6. Turn your grid on. Okay, now, this is the one that we've got to check. So which one of these matches that? I think it is B. B's the one. So check it out. This is easy, 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 easy. Anybody get 6 right? That was Adriana. She got 6 right. Okay, number 7. Here we go. Okay, 7. Check this out. This guy's easy too. This is not bad. Now, what are the approximate? So approximate means you're just going to kind of guess. It's an estimate. So what are the approximate zeros for this function? Okay, this function right here is graphed. Your zeros are easy. Hannah, your zeros are right here. Put a dot there. Put a dot there. It's your X-intercepts. Those are the zeros. So that means this. To get to this dot on the right, they say approximately because it looks like it's between 2 and 3. It's pretty close to 2. So if you guess, maybe you're guessing like 2 1/4, who knows, 2.25, but the y is 0. Now this dot on the left is between 0 and 1, and it looks like it's pretty close to halfway, so I'll guess like negative 0.5 and 0. So this one matches up with D. Negative 0.6 and 0 and 2.3 and 0. So you got to remember this. This for sure is going to be on. The zeros, if they ever talk about zeros, they are talking about your X-intercepts. Okay, number 8. This one looked pretty intimidating. Okay, but now look, check this out. We can do this. Let's do f of negative 2, and let's do g of negative 2. So they just want you to take negative 2 and plug it into g. If you take negative 2 into g, it's going to be negative 2 squared minus 6 times a negative. I'm replacing all these x's for negative 2's plus 3. Okay, we can do this with some mental math. Negative 2 times negative 2, that's positive 4. Negative 6 times negative 2, that's positive 12. And then I got a plus 3. So 4 plus 12 plus 3, 16, 17. This guy right here is 19. If I take negative 2 into f, this one looks a little harder because look, this one is f. If I take negative 2 into f, it gives me a negative 27. So here's how you know. You're going to take negative 2, you're going to plug it in place of x, so here it is. Negative 2 spits out negative 27. So which of these equals, less than, or greater than? This guy. 19 is greater than 27, or negative 27 is less than 19. So we're going to go right there. Now, holy smokes. Huh? This one's cool. Let's do this guy right here. If you plug 2 in, let's take 2. If you plug 2 into f, it spits out a 9. They're not going to give you this. They're never going to give you that. Guarantee. That's nasty. But this is not bad. Let's take 2 into g. If you take 2 into g, it's going to be 2 squared minus 6 times 2 plus 3. And the 2 squared, that cleans up to a 4. A minus 6 times 2 is a minus 12 plus 3. What's 4 take away 12? Add 3. 4 take away 12 is negative 8. Okay, negative 5. So now 9 compared to a negative 5. 9 is greater than negative 5. So we're going to go greater than. Now, check this out. Let's do the bottom one. And we'll call it good. Everybody please welcome Mrs. P. Shout out to Mrs. P. Okay, the bottom one. Alright, now Tyler, check this out. Let's look at the Y-intercept. Okay, the Y-intercept is this. It's where your graph crosses the y-axis. So this dot right here, that is it. If I have all these dots, if I go 0 down 1, that is my Y-intercept. So, and they want this. They want the y coordinate of the Y-intercept. So that's this guy, negative 1. Now this one's going to be hard. Actually, this is going to be a piece of cake. Do you know the y coordinate? Do you know the Y-intercept of this guy right here? Do you know the y coordinate of this? Y equals m, or the, do you remember what b is? That's, m is your slope. B, this is your Y-intercept. So now, City, This, if you've got, look at a quadratic. This is your y-intercept, just like it is in B. So 3 is your y-intercept, or just do what Austin did real quick. Just put 0 in for x. So if you put 0 for x, that's easy, that's 0. If you put 0 for x, that's easy, that's 0. So you get 3. So this is actually pretty easy. So -1 compared to 3. -1 is less. Anything to the 0 power is 1. Okay. Now, number 9. You got 4 functions. Function A, function B, function C, function D. F, G, H, K. Which of these functions has the greatest increase from the interval x is 0 to 10? So you're looking on the x-axis. They want you looking right here. So on the x, this is 0, this is 10. So this is where they want you to look. From 0 to 10 on the x, which one of these has the greatest increase? So let's do this. On your calculator, let's just ignore this guy, because we're looking in quadrant. We're looking over here on the right side of the x, and this guy's on the left side of the x, so we're probably okay. So everybody hit tab. Okay, tab. Let's punch this in. Punch in x plus 9. So let's type in x, add 9, hit enter. Then you're going to hit tab again. And this one is 9 times x. So just hit 9x, hit enter. Then the third one, you've got to go 9 to the x. So this guy right here, hit tab again, go 9. Okay, the exponent, hit this caret, left of 4, hit that little caret, 9 raised to the x, hit enter. And then the last one, what is the last one? X raised to the 9. Okay, hit tab again, and then you're gonna go x raised to the 9th power, hit that, ching. Uh-oh. Did it show up on your guys's? X raised to the 9. Oh, okay, there we go. Okay, now, so they want to know this. Which one of these 4 has the greatest increase from 0 to 10? So if you're looking at the pictures, geez, we can't even tell. 10's clear over here. Man. It's hard to tell. Which one are you digging? None of them? The old brown guy? Okay, let's try this. Let's do this. Okay, let's go A, B, C, D. Whoops. That did look like 10. Go A, B, C, D. Let's do it this way. A, B, C, D. Okay, let's put 0. Let's go from 0 to 10. What does 0 give you? If you put 0 in for x, what does it spit out? 0 spits out a 9. And let's put a 10 in. What does 10 spit out? If you put a 10 in here for x, what's 10 plus 9? 19. So now, Tyler, it went from a 9 to a 19. So how much did it increase? So this one went up 10 times. Okay, now let's look at B. Let's do the same thing. We're just making a table. And we're just going to put, let's put 0 for x. So what's 9 times 0? And let's put 10 in. What's 10 times 9? 90. So this went from 0 to 90. So it's definitely not A. Let's kill A. Because this only went up 10. This went up 90 times. Now this way is probably the best way. This is going to be... That picture is kind of confusing. Now let's look at C. Okay. C. Let's put 0 in for X. What's 9 to the 0? That's a 1. Anything to the 0 power is a 1. Okay, now let's put 10. What's 9 to the 10? You gotta do this on your calculator. Now look, on your calculator, we gotta go back here to page 1. And let's go 9, raise that to the 10. $3 billion. Okay, that's the number. Bunk. So this 10 is going to be 3 billion. So it went from 1 to 3 billion. Okay, now B's dead. C is the new winner. Now we just got to test out D. What is 0 to the 9th? What's 0 times 0 times 0 times 0 9 times? Okay, that's a 0. Now let's do 10. What is 10 to the 9th? So let's go here on the calculator. Let's go 10 to the 9th. It's only 1 billion. Ooh, 1 billion. So this guy gave us 3 billion. So we're going to go with C. Last one. Okay, number 10. This one is guaranteed going to be on. This is good. An angle theta lies in quadrant 1. So let's draw quadrant 1. Okay, tangent of theta is 5 over 12. Now tangent, you got to remember this. Tangent is TOA. So this piece is the opposite. This piece is your adjacent. So in quadrant 1, so check this out. You've got theta right here. You're going to draw a triangle. We're just going to make a triangle. It's going to have a hypotenuse, a 92 legs. Now here we go. This is theta. So this is going to be opposite. This piece right here is going to be the hypotenuse. This piece is going to be the adjacent. And they're going to tell you this triangle is 5 tall, because 5 is the opposite piece, and 12 is the adjacent. So 12 is that piece. And they want to know, on that triangle, if tangent gives you 5 over 12, what does sine give you? And sine is so. So we need the opposite over the hypotenuse. We've got the opposite. So it's going to be 5 over, we just need the hypotenuse, and that's what this is. So we're going to have to go Pythagorean theorem. We're going to have to go 5 squared plus 12 squared equals c squared. 5 squared is a 25, 12 squared is a 144 equals 169. So 169 is c squared. So you got to undo the square, square root, square root. So this piece right here is 13. So the answer is 5 over. So this one guarantee is going to be on the final and on the Sage. It's going to show up on both. Yeah, well, if you know the angle.